What we have here is a setup where we're going to take a look at how do you properly measure using mass and volume, and then use those measurements and figure out the concentration of a substance, okay? Now our goal here really isn't about solving for concentration. Our goal here is to follow the proper rules for measurement and then rounding calculated values, okay? So that's kind of our goal here. So here's what I got going on. First of all, I have a balance out here that's set to 0, and I have a cup of sugar, okay? And I want to take this sugar and I want to dissolve it into this water right here. And when I do that, I'm going to create a sugar solution. And that sugar solution will then have a certain concentration to it, okay? So to do this, I need to, first of all, figure out the mass of my sugar in this process so I can find out that numerical value of that concentration. So I put an empty container on my balance. I'm going to hit the 0 button to 0 it back to 0. Then I'm going to add my sugar, because this is what's going to be dissolved. Get that all in there. And I get 7.2 grams, okay? So at 7.2 grams, that's going to be my mass. So we're going to record that as 7.2 grams, okay, as my mass. Now, my volume that I'm working with, from this angle, it looks like it's about 50. But remember, with measuring volume, we have to get eye level with our container, and we have to make sure that we are looking at it from that perspective. So here it is. We're at eye level. Let it kind of sit here, and we'll try to focus it on that graduated cylinder. And you'll notice what looks like almost a yellow kind of curved line in there. And there's a top one and a bottom one. We're looking at that bottom curved line, okay? So if we count our layers or our lines here, we see there's a line at every 1 milliliter. So there's one at 50, 51, 52, 53, 54, 55, all the way up to 60. And that curved line, if we count, there's 51, 52, 53. It doesn't quite get to 54, okay? So this is where it becomes important to do our estimating. It's not 53, it's not 54, it's somewhere in between there. So then I have to do my best to estimate what that number is, so that can improve my accuracy of my measurement. Okay, it's not about precision here. That's a way to improve accuracy by adding in the estimate between two lines. It's actually one of the requirements of our measuring when you use analog measuring. Okay, we don't do that with the balance over here on the 7.2 because the balance gives us a digital readout, and we can't estimate off of a digital screen. Okay, so because I think the line isn't quite at the 54, it's just below that, I'm going to call this 53.9. for my volume measurement, okay? So, going back to my work here now, this is going to be 53.9 milliliters, okay? So 53.9 milliliters. Now, to get concentration, I'm going to take the mass that I have and divide it by the volume, okay? So my mass of my sugar, which was 7.2 grams, I'm going to divide that by 53.9 milliliters, okay? And then I'm going to solve this, okay? Now I'm going to use my dumb calculator, because calculators are dumb, and I'm going to take 7.2 divided by 53.9, punch into the calculator, hit enter, and my calculator gives me this wonderful answer of 0.133580,705. And that is, of course, it can't even label for me, but I know the label is grams per milliliter. So now my job is, where along this stretch do I round off my number, okay? Because I only had a certain amount of precision in my mass measurement and a certain amount of precision in my volume measurement. So I had to choose where to round this, okay? So to do that, I have to go up, and I need to take a look at what type of math I was doing. So since I was doing division, and division or multiplication has the same rules applied to it, I go up and I look at my measurements. So in this measurement right here, I have 2 layers of precision, or we call that 2 significant figures. So I have 2 sig figs here, or 2 measured values. In this measurement, I have 1, 2, 3. So in this measurement, there was 3 measured values, okay? The rule is that you can only be as precise as your least precise measurement. So 2 is my least precise measurement, which means that I can measure out one value, two values. This 0 is a placeholder only, so it's not part of this measurement. So I am going to round it at my 3 right here, okay? Because the 3 behind it is less than 5, I now can keep it as a 3. So my final answer would be 0.13 grams per milliliter. Is my final answer, okay? And that is the proper way to do this. So it's accurate to the best of my measuring, and we have also matched the precision of the tools that we were using in this thing. Thank you.